Hello and good morning to everybody. Good morning in Europe, good afternoon in China, and good night in the US if somebody listens from the US. Welcome to our webinar, to the integrated monitoring for wind turbines. If you have any questions while this webinar, please feel free to use the GoToWebinar tool to send your questions. We will try to answer the most questions while the webinar, or some of them at the end of the webinar, and in case we can't answer them, we will get in contact with you after the webinar. And also we are very open, so get in contact to us and ask us for specific topics if you have any interests or needs for further meetings. Yeah, we are open to arrange something for you. We have a tight schedule today, so I will start with an introduction for monitoring solutions and new automation technology. Then we have the peak analyzer from the company GFM. Afterwards, the tower monitoring from the company Whirlpool. The power measurements from Beckhoff Automation. Then we have the monitoring of drivetrains from CMS at Wind, as well as strain measurement on blades from company Line Linde. Berger from Beckhoff will introduce the Twinklet Flex meter. We will see a presentation about pitch systems from company Artech. We will see the pitch control solution from the company Polytech together with Aerodune. And at the end, I will close this session with a measurement technology topic. So let's start with the introduction about new automation technology, and I will introduce why we offer this platform here for all these partners, because we think that Beckhoff offers a very good solution for the integration of monitoring solutions into the control system. If you take a look at classical control systems like here, yeah, they look very impressive with all these cablings and all these different systems which are connected here. If we take a look to the topology, then they use a proprietary hardware together with a proprietary operating system with very specific or uncommon field bus systems sometimes, or specific internal communications, as well as proprietary firmware. So the whole system becomes a closed system. So it's not easily possible to connect or interact with this system. And we see a similar issue in the wind turbines nowadays. So we see there's different monitoring solutions in the turbine, and all of them are quite closed. So they are connected to the main control system in the most cases, but they don't offer all the informations and the internals to the user, to the wind turbine manufacturer. He buys it from any third-party company as a black box, as a closed system. So he needs to do some work to interface the system, because it's most of the case not a very open interface. It has a specific own hardware with an own CPU, own infrastructure. It needs data from the main control system, which the manufacturer needs to interface and offer. And then the system is closed, not synchronized with the main control system. It has specific data formats. It has concentration of the data. It doesn't offer you all the raw data of the sensors, but only calculated values or mean values or any concentrated values and limited values. And then you have many different hardware suppliers in your machine, and you need to maintain everything and do service for everything, learn all the specific informations for everything. And this means also a very high cost level, not only in manufacturing the turbine, but also on the lifetime of the turbine. Beckhoff offers a PC-based control, and you see already this much nicer looking cabinet here, which much less cabling between all the modules. And this technology is based on several milestones we did at Beckhoff. Especially in 1988, we started with PC-based control. So a standard PC we used for control system. In 1995, we invented the bus terminals with a universal module to interface signals from the field. 2003, we invented EtherCAT, the really fast real-time Ethernet field bus. And 2010, we started with Trinket 3. That means the bus terminal, for example, is a technology driver since over 25 years. So Beckhoff is very driven by new technologies and not just the last years, already since over 25 years. So the platform is based on a common PC architecture together with a common operating system like Windows, or with the Trinket BSD based on FreeBSD, which is very well known, both of them, in the industry. Then a standard field bus, which is EtherCAT in our case, and we use standard programming tools to implement the firmware, like C++ programming, the IEC 61131, or MATLAB Simulink to generate Trinket modules. And we have a lot of standard interfaces to connect and interface the system. So altogether, the PC-based control, an open platform with open interfaces and open mechanisms. The hardware is based on our industrial PCs and embedded PCs. And in this case, we are very modular and where we have many levels, from low-level ARM CPUs up to many-core Xeon CPUs. We are very scalable, and you can choose a industrial PC or embedded PC for any application. To interface, I already discussed about the field bus, which is EtherCAT. And EtherCAT has already become a global standard. So it's the biggest community for Ethernet-based industrial communication, the EtherCAT technology group. So it's a very widely used standard already, with over 6,000 members and several manufacturers which offer EtherCAT slaves, EtherCAT masters, drives even, and so on. And this offers us the big amount of different modules and hardware components, which are very modular and flexible, combinable. You can combine an embedded PC or a bus coupler together with all these different terminals we have for a lot of different signals, even very accurate and high-end measurement technology down to IP67 modules, or nowadays even ELX terminals for the process industry. And also the EtherCAT plug-in modules to connect them directly on the board. So very flexible and modular hardware here. Combinable with the performance of EtherCAT. So we have full duplex 100 megabit communication down to every slave. Without changing the protocol, it's still EtherCAT. So every slave internally communicates directly with EtherCAT, directly exchanges its information in the EtherCAT frame. And this means we don't need any subsystems or subcouplers, which saves a lot of performance. And it has specific technologies like the oversampling technology, which allows us to sample very high frequent data. 50 kilohertz is nowadays common in our terminals. Theoretically, it will go up to 1 megahertz. And all these signals are also very time accurate because of the distributed clocks technology inside EtherCAT. Every signal gets a timestamp with a resolution of 1 microsecond, and the synchronization is better than 100 nanoseconds. And that means also events in the system, we can give it a timestamp, like a digital input terminal with a timestamp, and very exactly measure when it happens and where it happens. The EtherCAT measurement technology offers these metal housing terminals, which are easily interfaceable also to the plastic housing IP20 terminals from us, and offers these high-end measurement technology with 100 ppm accuracy, up to the 50 kilohertz of sampling, and a 24-bit resolution of the signal. This was the hardware. To the software, we have Trinket 3. And Trinket 3 offers this modular software based on this Trinket modules. So we have the Trinket 3 real-time, and inside the real-time, we interface by these component object model standard, all the different modules which are coming from all the different areas, like a PLC module written in IEC 61131, a C++ module, a Simulink module, even safety modules are based on this TCCOM standard. So these are very unified modules which have all defined and unified interfaces, makes it very easy to combine different modules. Not only Beckhoff modules, also third-party modules can be interfaced here into the software. And this offers this platform for software integration of third parties like the partners we will see later. And you say, well, we have now all these high-end monitoring solutions with a lot of algorithms needing a lot of performance. And because our CPUs are already many-core capable, also Trinket 3 is many-core capable, so we can easily choose on which CPU core which part should run. You can have one CPU core for the operating system, another CPU core for your main control, and another CPU core for your monitoring solution, and even further CPU cores if you choose the right CPU in this case with maybe 8 or 16 cores. To interface Trinket, we have a lot of open standards. So as I already said, Trinket 3 is open in the modular approach, but also by external interfaces. We have the basic Intel processors, basic operating system, Visual Studio for engineering, and the programming interfaces, but also EtherCAT and all the other field buses like Profibus, Profinet, CAN-Open. We have all the interfaces to other communication ways like OPC UA, the IEC protocols. Even IoT communication is possible. We can store files and store into a database, and this offers a lot of possibilities to interface the data, get the data from the system, and use it all collective. So coming all together into a system integrated condition monitoring means using these open platforms and these open technologies to interface it. We have the control system, maybe an existing wind turbine control system. We just interface some more hardware. We put some more terminals to that, or put them already into the main control system, or interface it here by a coupler, add some measurement terminals, and combine it with software modules to establish this monitoring application. And this offers us to bring everything together on one hardware with one interface and one solution for all tasks. So we collect all the raw data with EtherCAT and down to 50 kilohertz. Everything is time synchronized over the whole system. Everything can be stored in the same data format, in the same database, on the same CPU. We have the terminals to interface nearly all the signals you need, like IEPE sensors or anything else like strain gauge systems. And this is easily interfaceable because it's already part of the main control system, and it doesn't need any subfield bus or subsystem or specific communication or proprietary communication. And that means also all the data is already there, like the wind speed or the power or the drivetrain rotation. The main control system already knows that, and inside the software, combining these Trinket modules is just an easy configuration and a mapping between the data signals and the data values. So means the third-party partners, as we see later, offer now software for this to implement their specific knowledge of mechanics or vibrations into a software module and integrate this into the Trinket platform. The licensing then is also opened by Trinket, means the third-party suppliers can also license their modules and use the same licensing mechanisms as Trinket uses them. And this also gives the ability to implement own measurement applications, own measurement boxes, add them to the main control system or integrate them to the main control system. And this is how a system could look like. With all the third-party suppliers, you add some measurement terminals, which are required to measure the signals for the specific monitoring applications. And then you get some software tools or software packages or add-ons you install to the system and interface to the Trinket system. And this offers you to integrate the monitoring application. So let's see a first application like this, which will be offered from GFM, from Christian Reinecke.